Okay, so this is objective 7.2b, and unit 7.2 has many components. I think we'll go to 7.2 E or F, depending on how I think we should break it down. And then that'll be the end of unit 7. The topic for today is the special right triangles and some application of trigs, some word problems. Your essential question: can I explain the relationship of the sides of the special right triangles? And can I use trig to solve word problems? Okay, so first, let's start with what are the two special right triangles, and I did introduce them to you when we were working on your warm-up this afternoon. So these are the special right triangles, and it would be a good thing to learn these relationships and have them just committed to memory and easy to access, because you will you will solve a lot of triangles that are special right triangles over the rest of the semester. So we're going to start with this equilateral triangle right here. That is not a right triangle, but it is an equilateral triangle. And so what I would like to do is pick up my green pen, and I'm going to relate the 30-degree angle to the short side, and I'm going to label the short side A, okay? And they are related to each other. They're opposite. So the 33-degree angle is opposite side A, okay? And then for the 60-degree angle, I'm going to do that in red. And it has a relationship to its side, which is the side length opposite will be A times the square root of 3. And then the 90-degree angle, which will be the last angle in this right triangle, will be opposite the hypotenuse, which will be twice A. Now, typically when you see a special right triangle, you watch a video on them, the ratios won't be A squared to 3, 2A. They'll be X squared to 3, 2X. A is just a variable. You're going to plug a number in for A or X. It doesn't matter. It's just that I'm going to ask you to find X and Y often today, and I don't want you to get confused. So first, let's go ahead and pick up your red pen now. And just in these bottom two angles, this is an equilateral triangle. We'll put 60-degree angles in. Okay, so here we have what's called an equilateral triangle. If these two are 60, the last angle has to be 60, but we're going to cut it in half, so don't label it 60. And what I'd like you to do is we're going to cut this 60-degree angle in half by drawing in an altitude. So come perpendicular to the base, like so. Okay, and let's label that side A times the square root of 3, because it's opposite the 60-degree angle on both sides. And then maybe just grab up your blue pen for a second, and let's drop in a right angle. Now, I'm going to go to my green pen, and I'm going to label this 30-degree angle up here. I cut the 60-degree angle in half when I dropped in the altitude. And I could put it on either side. I think you're okay with one side, right? And remember the relationship between the 30 and the 60. If 60's opposite side is A squared root of 3, then 30's opposite side is A. So we're going to label this A, right? And so this side over here would also be A, wouldn't it? Mm-hmm. So if we put those two together, we get, I switched to blue pen, what do we get? And if that side's 2A and this is an equilateral triangle, this side is also 2A. And this side over here is also 2A. So opposite your 90-degree angle will be a double length of the short side of your right triangle, like we talked about today in your warm-up. So this is the relationship. Anytime you're given a 30, 60, 90 right triangle, if you can access this information, it makes the triangle a little bit quicker to solve. You don't have to rely on trigonometry to solve it. However, if you want to rely on trigonometry to solve it, you may. So here we go. Let's do 2 quick practice problems and see if you can use these relationships between the sides to answer this question. So here I'm going to draw a triangle. Let's see. I'll put the 30-degree angle down here. So we'll make that 30 degrees and put our right angle in. So we'll start off with a simple one. If the measure of this side here, this is a 30, 60, 90. If the measure of this side is 3, solve for x and y. So the thing that I typically will do is I'll just go ahead and grab my relationship. My opposite of 30 is supposed to equal a, and my opposite of 60 is a times the square root of 3, and then my hypotenuse is 2 times a, that relationship. I'm going to color code just this once here. So this is a. So a equals 3. Here we have a times the square root of 3. And opposite our right triangle, our hypotenuse, we have 2 times a. So here's what I know. A equals 3. That's what I know. So can't I just plug a into these other 2 sides and find what x equals? All right, so x equals, what do you think? Plug in a. A equals 3. Plug in 3. Square root of 3. You got it. And let's do y, or the hypotenuse. So again, you're plugging in a. So 2 times 3 is 6. And so, alternative way to solve this right triangle without using sine, cosine, or tangent. Now I'm going to challenge you. Okay, so let's say that I give you this picture. Who's got the hiccups? We're going to solve that right now. Get rid of them or you're going to come stand over here by me. Okay, so let's go opposite 60 and make that measure 5. So now I'm challenging you a bit. How are we going to find the measures of x and y, or the short leg and the hypotenuse? What are we going to do? Could I go through that same process again? What do I know about side opposite 60 degrees? What does it equal? A square root of 3, right? And the side opposite 30 is supposed to be a, and the hypotenuse is supposed to be 2a. So how could I figure out what a equals? Because my long side, which usually, or my long leg, which usually is got a square root of 3 in it, is a whole number. It's 5. How do I solve this for a? I think dividing by the square root of 3 is a great idea. Let's do that. So we would go, all right, so a square root of 3 equals 5. So a equals 5 over the square root of 3. Now your calculator, when you plug that in, it will rationalize for you, but I'm okay with you having this answer for now. So we know now that x is equal to 5 over the square root of 3. Now we just have to find y. So to find y, we would say 2 times a, right? Over the square root of, so 2 times 5 over the square root of 3. This is what y is equal to. So what would my answer be? 10 square root of 3? I don't think it's 10 square root of 3. I think it's 10 over the square root of 3. Or it's 10 square root of 3 over 3. Your calculator would probably tell you it's 10 square root of 3 over 3. because the calculator will rationalize the denominator. It'll say, I don't like that in the denominator, so it'll go, all right, I'm going to clear it. Square root of 3 times the square root of 3 is 3. That gets rid of the radical. But I have to multiply fractions times 1 if I don't want to change them. So that would be 10 square root of 3 over 3 if we were to rationalize it. But I'm okay with you leaving it with the irrational in the denominator. Got it? Questions? All right, let's go back to the other one quickly then. So this other one, I'm just using red and blue on this one. Go ahead and grab your blue pen and let's put the 90-degree angle in there. And then grab your red pen and let's put the 45-degree angles in there. So this is a 45, 45, 90. Then we'll come up here and we'll write the relationship. So the 45, 45, those are the angle degrees, are the same length, so we could call them both length A. And then our 90-degree angle, which is our opposite or hypotenuse, is A times the square root of 2. And this is the relationship. So I'll go ahead and put those in there so that you can look at it in two different ways. That's a little bit messy. I should have answered that question a little bit better. X equals 5 over square root of 3. Y equals 10 over square root of 3. Write it down nice and neat on your note page. Okay, so there's the relationship for the 45, 45, 90. Always a little bit easier to solve these. So let's draw a 45, 45, 90. I didn't mean to draw that in my red pen. I didn't mean to. All right. So it's a 45-degree angle. I'm doing everything backwards here. All right. And let's say that the hypotenuse is 4. And I want you to find these sides. And I want you to do it quickly. So here's what we know. The opposite sides of 45 are A and A. And the opposite of the right angle is A times the square root of 2. And we're going to solve for A, right? So that'll give us the length of side X and side Y. So quickly, how would we do that? Divide by the square root of 2. So A square root of 2 equals 4. So A equals 4 over the square root of 2. I got to tell you, you're going to want to simplify this because 2 does go into 4. So if we rationalize our denominator times the square root of 2 times the square root of 2, here's what we get. 4 square root of 2 over 2. And don't forget that I can simplify this right here to 2 square root of 2. So the measure for X would be 2 square root of 2. And of course, the measure for Y would be the same. So come up with a method that works for you, that helps you to apply those relationships until you can access them easily when you see a triangle that has a 30, a 60, or a 45-degree angle. You'll get some practice with your assignment. Reference your notes. Now, the other problems that I'm having you do today, some of them do apply to the 30, 60, 90 or the 45, 45, 90 rule. And some of them are just random triangles. So my challenge for you is to turn each of these word problems into a right triangle and either use sine, cosine, and tangent to solve for the missing piece or the thing that you're looking for, or use your special right triangle ratios to find the answer. I'm not going to do these problems for you. I'll give you 5 minutes to get them done, and then I'll turn the video back on and I won't work the problems out, but I'll have the setups up on the computer or on the screen so you can check your work. Your homework for tonight or for the weekend is on the same assignment as yesterday's assignment. I'm just going to ask you to do problems 9 through 14 and practice your special right triangle relationships, and then do problems 21 through 24, which are just changing word problems into right triangles and using your triangle relationships or your sine, cosine, tangent rules to help you solve them. So calculator's handy. Okay, I'm going to press pause, give you 5 minutes to work on those 2 word problems. Work with a friend if you need to. Okay, so there's the 2 pictures drawn for each word problem, and then in the first problem right here, I used the rule for the 30, 60, 90, and I also went ahead and used tangent of 60 and used trig, depending on what you were more comfortable with. On the second one, I didn't have special triangle rules because it was a 63.2 degree angle, so I did have to use the tangent because I wanted the opposite and I had the adjacent. So I used tangent of 63.2 equals x over 15, then I solved for x. And so don't forget, homework 9 through 14, 21 through 24 on worksheet 7.2. Have a good weekend.